Hello S4 students. Today we will start chapter 5.2 Basic Rules of Differentiation. So in this video we will go through 4 theorems from 5.1 to 5.4, and for the first two I will also show you the proof. Okay, let's start. Okay, theorem 5.1. Okay, if fx is a like a constant function, then we will have the derivative equals to 0. Okay, first of all, this we call it constant function. It means the function is actually a constant number. So let's look at the proof. So for the from session 5.1, you have already learned that f prime x will be equals to this, right? Okay, and then now as fx equals to k, so no matter what x is, it will be k. So this is k, and naturally also this is k. So the numerator is 0 and the denominator is tends to 0, but it is not 0. So we will get 0. Okay, so we got the proof. Okay, for theorem 5.2, this is not a constant, but it is x to the power n. Okay, in this situation, n is non-zero real number, so it can be negative as well, and also it can be fractions, like for example 3/2, or even an irrational number like square root 2. And this kind of function we call it power function. So now let's look at the proof. When we look at the power function, this will be the result. I'll give you more details about this, or how to remember this one. So let's start with the proof. Again we will get this limit, and then we try to put the function. So we get this n minus x to the power n. And then for the first one, we use binomial theorem to expand it. So x to the power n plus nc1 x to the power n minus 1 plus, not plus, it's still missing the delta x, and then plus nc2 x to the power n minus 2 delta x squared, and then up to the last one. So this will be the expansion, and then we minus x to the power n, and then over delta x. So actually, you may notice that these two will also cancel with each other. So we will get limit delta x. And the delta x, you can take it out. So you get nc1 x to the power n minus 1 plus nc2 x to the power n minus 2 delta x, and then up to delta x n minus 1. So these two again you cancel with each other, and then you see when delta x tends to 0, actually all this term will become 0 because they all have delta x. So finally we will get nc1. nc1 actually is equal to n, so we get nx n minus 1. So how to remember this one? When you want to like differentiate x to the power n. Then you try to look at the index, and then you put it in front of the term. So you will get nx, and then you minus 1 from this n. So it become n minus 1. Okay, so just remember, you put the index, okay, in front of the term, okay, becomes the coefficient, and then you minus 1 from the index. Okay, so here we will quickly go through some questions. Okay, let's try to do this 9 together. Okay, for the first one, this is a constant number, right? So differentiate a constant number, you will get 0. Okay, for question 2, as I said before, now x to the power 6, right? X to the power 6, then you put the 6 in front of the term, and then this is 6 minus 1, the index is 6, and then minus 1, you can put 5. Okay, for the first one, okay, it's negative number in the index, but it doesn't matter. We just apply the same rule. So we put the negative 2 in front, and then negative 2 minus 1, and then we get negative 3 for the index. For this one is a fraction, but it doesn't matter. You still put this number here, and then we get 7 over 3 minus 1, so we get 4 over 3. And this x to the power 0, so if you remember here, we must have non-zero real numbers for the index. So how to do? Don't worry, x to the power 0 is actually 1, right? So it's simply like the same as differentiate the number 1, and then so you will get 0. Okay, for question 6, negative 3 over 5, and then negative 3 over 5 minus 1, so you get negative h over 5 here. And this one, how to do? So for these questions, we always need to change it to x to the power negative 4 first, okay? So you won't get mistake. So we must have the form x to the power n, okay? So now we get negative 4 here, and then x, and then negative 5. And this one, again, we need to change it to x to the power n, so x to the power 1 over 3. Okay, so and then you get x here, and then 1 over 3 minus 1, so you get negative 2 over 3 for the index. And then e, do you remember what I remind you? Okay, when we talk about this number, actually I give you the hint, it's the number, right? Number, so 0, you differentiate a constant. So got it? So now we get another 2. Theorem 5.3. Theorem 5.3 means if you get a function, you try to differentiate the function, but if you have a constant k, so you can imagine k is not relating to x, right? So you can take it outside the differentiation like function, then you can do it. And then for the theorem 5.4, addition rule, you differentiate this one, okay, the whole, and then you can like differentiate each one, okay, and then you add it afterwards. So similarly for the minus. So actually here we also have the proof, but I think you can handle this, or you can try to look at, okay, for the first theorem 5.3, you can refer to page 5.12. There is a proof there. Okay, for the theorem 5.4, you can refer to page 5.14. Okay, if you're really interested in the proof, but you still can't understand the proof in the textbook, you can approach me. Okay, and I will explain more to you. Okay, so now I would like to go to one example. Okay, and we'll end this session. And actually, in session 5.2, we still have 2 more videos, okay, in the coming 2 weeks, okay, for you to explore more about the product rule and quotient rule. So let's look at them later. Now, example 5.6 for part A. Find the derivatives of the following function with respect to x means we try to find dy dx. Okay, so first maybe we try to copy the questions and then dy dx. So here we get addition, but we can do that separately and then we add them, okay, afterwards. So we try to look at the first one. So for this one, we get 3x to the power 3 minus 1, so we get 2, right? And then for this one, the second one, actually the 2 is constant, so we can take it out first. Okay, we ignore it. And then we try to differentiate the x to the power 2 only. So for the x to the power 2, then you get 2x to the power 1, right? So finally, we get this answer. Okay, and then for part B, now we try to look at the questions. 6x squared minus 1 over x squared. Okay, as I said before, we better change it to the form x to the power n first. So we change it to this one. Okay, again, we try to apply the rule. So 6, we keep it. And then x squared, we get 2x to the power 1. Okay, you can just simply write 2x instead of 2x to the power 1. Okay, and then minus, here we get the negative 2 here, and then x negative 3 over the index. And then we try to simplify. 12x plus 2x to the power negative 3. Okay, here we can use x to the power negative 3 as the answer, okay, unless the question asks you to express the answer in positive indices. Okay, so those are some basic rules, okay, we learned in this video. Later we will learn some more difficult one, so let's have a quick review. Okay, for the first one, differentiate a constant number, we will get 0. And for the second one, differentiate x to the power n, you will put the n in front of the term, and then you will get the power minus 1. And then for theorem 5.3 and 5.4, okay, the k, you can ignore it first, okay, you just try to do the part you want to do. Okay, and theorem 5.4, you can, for their addition or subtraction, you can differentiate them separately and then add or minus that afterwards. Okay, so this is the end of this lesson. Okay, so now you are going to do some practice to familiar with the skill you just learned. Okay, see you next lesson.